Greetings. This is Roger Shaw and Travis Shattle. We're doing a video on the technology that comes with Wood CAD/CAM, and we're focusing the video on making one-of-a-kind type products. There's multiple strategies nested into Wood CAD/CAM that enable you to take many different types of approaches to using the solid modeling technology that is controlling. In addition to that, I really want to show you how important it is to understand and use an SQL database to control the data as you enter it in to the system. It's not just enough to be able to create DXF files that can be put somehow into a machine. What really is the goal is to develop a one-of-a-kind product that is also parametric and also has flexibility in terms of when it hits the manufacturing floor and accommodating their needs. So let's go ahead and get started, Travis. I guess the first thing you're going to do is build, they have this thing called Article Designer, and we're just going to use a standard designer system to build a typical one-off. You'll notice on the top right-hand side you got height, width, and depth, and you can adjust that. And this little shadow box that you attach parts to, it's pink, and it recognizes every side. And then what Travis is doing is nominating the material and the construction strategy for all of these parts as he goes forward with it. You'll see that you can think in terms of how the overlay is, which he's doing right now. It enables you to address all the construction strategies involved with putting this assembly together. Here he's putting a back on, and now I guess he's going to go ahead and put some divider shelves in there. And you'll notice down here it has a first linear division. You can nominate it out as 1 by 1 by 1, which would divide it up equally. Or you could go back and space it out however you want to put it to space it off in different sections of the box. From here, he's going to go ahead, and you'll notice that this one big container now is 3 smaller containers. And on the bottom third, he put in 2 drawers, and now he's working on the middle section of this article. And we'll see what he's going to put in there. He's putting in some dividers on the right-hand side, and which also makes individual boxes that you could add more parts to. Now he's putting a door on the one cubby hole in the center, and on the top, he's going into the top now, and I guess he's probably going to put some doors on that. So it's a very, very fluid, fast system, and it's looking into the database at the defaults, unless the parts are nominated to have different types of changes. Now he's going ahead and saving the article, and now he's going to go ahead and place it into the 3D space in model space. You'll see on the left-hand side, it's got, even though it was designed at 70 inches by 40 inches by 20 inches, he could change that. It's parametric at this stage. So he goes ahead and puts it in, and Wood CAD/CAM takes over and draws it out with all the machining in it. And there it is in a realistic view. It's true solid modeling. And then if you open it up into a wireframe, you can actually see the joinery and all that. The neat thing about using the AutoCAD solid modeling functions versus the other stuff that's out there, Inventor, SolidWorks is this stuff is much more efficient in using RAM, and you can get a lot more into the model rather than just one object. We can lay out a whole bunch of objects or articles to make your submittals and to communicate with. So it's a pretty neat combination of both solid modeling and 3D wireframe. 3D wireframe is also solid. So that's how that's a basic fundamental one-off method that this system deploys. I want to show you that how you can change the joinery by having it look at the database. So Travis is going to click on the variables of what this object or article is looking at, and that's that $ at the top left. And here they've got a little bit of a lag in the system. So he's going to go ahead and change just to give you an idea. This is what I think is so vital. You know, everything in the drawing is looking at how you want to build this system. And this is set up by the user. So these parts have default values, or they can be connected to variables. In this case, he's changed some of the variables and is going to deploy them, I'm assuming. So okay, it was a dowel, and now it's dado and screw. Okay, so can you zoom in and show the dado? If you look at the bottom, you can see that it is dadoed in there. So go over to the left corner a little bit more, zoom down in there. So you can see the dado. Oh, okay, I've got a lag in the system. Can you just change it again to just go dado? So I just want to just show you, because you know how the important property of WoodCAD-CAM is you literally have an SQL database that drives the drawing even after you've customized it. So when changes come through or accommodations, see, there it is, dadoed strictly. So that's amazing to me. It does it for materials, it does it for hardware, it does it for everything that's involved. Your construction strategies, everything is covered by the SQL database, if that's the way you've launched and used the strategy available to you in WoodCAD-CAM. It does require some thinking about how you're going to do this long term, but I've talked to many companies that say everything we do is different, but we do it differently the exact same way. And I understand that statement. If you do a lot of one-offs, you probably do too. Travis is now doing another one-off, and he's actually drawing out the footprint of the article that he's going to design. So he's at the floor plan level. He just drew a polyline. He could dimension it off and use all the AutoCAD functionality to get this right. So now what he's done is that function of the polyline that he drew on the floor is now in the article designer. From there, it's parametric, so he just made it 50 inches taller, and he kept the width and the depth the same. And now he's going to add the parts to it. So that shadow box has, it represents everything that needs to go into it, or it could be left blank and just have air. But the bottom line is that there's the buildup that he's done, and he can go in and put shelving in it, and calculate the way the shelving is going to go in, how many, how they're going to be spaced. Am I delayed here? So he's putting that in right now. So based on the fact that he's got 1 by 1 by 1, and then he's got a 26-inch deal there. So, and again, all of this is solid modeling, and it's all looking at the SQL database to figure out how it's going to be joined together. So it can be as complicated as you want. You'll see that now he's getting ready to put it into the 3D space or the model space, and there it is with the machining on it. So you can show that as a realistic. You can kind of get a feel for that. That is machine code ready, by the way, and it's also at the end of this exercise. We're going to be able to make some very sophisticated reports that took years and years of programming to be able to come up with the type of report that, frankly, our industry needs and has never had before. Oh, I see he's putting you're able to actually put machining on a part in the 3D space, and it picks up. So what he did is he put a hole on the top of that shelf, and he's going through the process of assigning the machining to it. So let's see how that, he goes down, he's picking the hole, and it'll go ahead and recognize it, and there's the hole in the part. So you don't have to pull the part off into some other space and do the massage on the part and then put it back in to the 3D model. You can do it right there on the model itself, and that is machine code ready. So we found that to be a real extra bonus. Hadn't seen that with other products that we've represented in the past. Frankly, the one-off engine in Wood CAD/CAM, we just did not know how advanced it was. Now, excuse me. Now we're doing a side view and making a one-off out of a right side view. So you have the standard solid modeling one-off that comes basically with the box that you're looking straight at, and it's going to go ahead and name it. And so now he's picking the side view, and there it was. It was just the right side was drawn into a shadow box, and now it's a matter of him changing the height, width, depth that he wants. And then he'll just start adding parts to it. Again, as he adds the parts, it's the parts are looking. They can either be looking at the database. If there's a $ in front of the material, that means it's looking at the SQL database and building it to the job that's being executed or the default job. This is huge in terms of how flexible the system is. It's just a matter of changing the database to have it built the way you want it built, or building the individual parts and then reusing them over and over and over again in multiple fixtures. So keeping in mind the strategy for a user would be to design his parts, design his sub-assemblies, and then design his full assemblies. We present you with a catalog for normal AWI boxes, but we found that the price of the front office in terms of engineering is between 10 and 30% because of these one-offs. And if we can get these one-offs done in a much faster way, we can drive that cost of front office engineering down below 10%, which is really pretty good for our specialty houses that build store fixtures and showcase items, along with the case good manufacturers who are having to deal with the reception desks and things like that, and storage elements like what you're looking at there. So that's another design strategy just draw the side part and make it happen. So, oops. So I'm not sure where his next what he's doing now, but oh, I guess he's going to change the material. He went out to the database and he changed the material, so it shows up as a different type of material. If you think in terms of material management, if the database is pointing at one material and the thickness of that material changes, it's a matter of one button going in and change the thickness in the library, and the G-code would change. And this happens a lot. You know, you mic your material and it doesn't come in the exact size that you thought, but it does. They all at least are in the realm of the same, just inaccurate measurement. So you can go in and change the thickness and before you drive the G-code on the element or the articles, and it will adjust. That's a huge advantage with a database, SQL database, that you just don't really get with just a solid modeling program. So again, I can't emphasize enough how important it is not just to have a solid modeling program, but to also have it connected to an SQL database. So as you drive the engineering product, it hooks up to the elements of variables that enable you to change on the fly that original design. You can't get there without that database. It's cool. There are a lot of things that are real fast and all that with solid modeling programs, but bottom line is we got to get this up on the tool as fast as possible, and we have to accommodate all the material changes and all the customer changes and all the field measurement changes, and the fluidity of being able to do that really fast comes from being able to have a SQL database or a database drive the finished drawing to fine-tune it for real life. Here he's using another strategy of building up a one-off. I'll let him go ahead and finish this thing. So, but the important thing is that he did a front element, and the system took the front element and drove it all the way through to the shadow box, and now he's plugging along with the shadow boxes with the parts put into the shadow box, and moving forward with the design as he pleases. So he's still massaging the shelves differently. Now he's gone into, as the shelves create sub-assemblies, so to speak, he went ahead and put in some dividers on one section. And again, here he is putting it into the 3D model space. And the bottom line is now he's got elements that that he formed by drawing it from the front. So you have drawing it from the top, from the front, or the side, or you can start out with a square box and work with that as a default. So that's 4 different ways or strategies to do solid modeling, one of a kinds, with WoodCAD CAM. We have another element or strategy that we find to be pretty interesting, and I guess he's going to get to that next. But to describe what it is, I'm not sure what he's doing now. Oh, he's going to check out the joinery for it.
Took it out once I deleted this piece.
Oh, okay. He deleted some parts, so it took out all the joinery. Is that what you're saying? Okay. Sorry, we're working together on this. So going forward, are you ready to do the?
Yeah.
Okay. Going forward, this is another strategy that gives you a jump start on how to do reception desks and reception counters and whatever. The system has the ability to take in a side view or an elevation view of a reception desk, and it has the ability to extrude it along any polyline that you want. So what he's doing right now is he's drawing a polyline that would look like a reception desk. Okay, then he's going to go ahead and draw a polyline for this section view to follow. Now, it seems mentally that I don't know how this can actually make a reception desk. It seems like it's just extruding that sectional view, which is good, along the polyline. So on the left you've got the section, and on the right you've got the polyline. So he goes ahead and chooses the insertion point of where the section view is going to run, back bottom left, and then he chooses the polyline, and there it is, done. Now you'll see the turning of it, and there it is extruded out, and it almost looks like, oh, okay, that's nice, but what about making this a reality? Well, you can use AutoCAD to do the slices. You don't necessarily want to have the joinery at the corners. You can cut them anywhere you want using AutoCAD, and it will accommodate the cut list that way. So, but there's a lot of information in that extrusion right now, and so to conclude, what this does is that we want to show you the output of how what we've designed. We've gotten 5 different designs down, and so let's see how it takes it and makes it into a report. I'm not going to deal with G-code today and nesting. This is just really primarily to show you that the WoodCAD-CAM system captures a tremendous amount of data, and it'll flow it into reports. And it's the only product I know of that can do one-of-a-kind type stuff like this, and literally go through and pick out all of the individual parts and put 4 pictures of the article that's been designed custom, and he's getting ready to be able to show us 4 pictures of the custom design, and then a picture dimensioned off of every single part. So here's that first one off that he did, and here is the parts below it. Each individual part is drawn out, and there's the labeling part up above it. So everything is drawn out and dimensioned. Here's the second one, same story. And what I want, the interesting one is going to be the last one that he did. There's the top down, and there's the one from the front. And I want to see how this. Here's the reception desk. And let's see the parts below that. So there's the base plates, and it's pretty amazing stuff. How I figured all that out. You're probably going to have to add in the stud wall to that, but boy, that sure does jumpstart you. So that pretty much concludes what I wanted to show you. Again, the emphasis is on, this is true solid modeling within AutoCAD. If you try to do this without a third-party software, it would be kind of difficult, much more difficult than it is in Inventor or SolidWorks or stuff like that. But with this, you actually get the information you need to put it up on the machine tool with great speed and true solid modeling. along with wireframe that enables you to do much, much more with your computer. Really do appreciate your time. I hope this has been informative, and you have a great day.